Can you please, all of you, let me know your name and in what technology you have been working on, so that while for the going classes it will be very much easier for us. So can we start with Rahul or Vamsi Priya? Hello. Yeah, go on. Please just tell me your name and on which technology you're working on.
Yes, my name is Vamshi Priya. I am working as a QA lead right now. So I came across Mulesoft and I just wanted to understand what goes in and what goes out for this. So here I am today. Thank you.
Oh, hi, Vamshi. Next, Sarita and Rahul, anyone can take lead.
Hi, am I audible?
Yes, yes.
Okay, yeah, so I am Rahul and I'm working on Mulesoft itself. Earlier I was working on Oracle, SOA, and currently I've switched to Mulesoft.
Okay, good. And I can see Sarita. Okay, no issue. So yeah, very good morning one more time, and we'll just start with. So before what we'll see what was Mulesoft today. We just wanted to see what were the key terms involved in Mulesoft. Okay, so firstly we'll just know what is an API and what is a web service and what is a middleware integration. First of all, why and in those middleware integrations, what was the importance of Mule ESB and why Mulesoft is trending currently this much at these times? And there was something known as point-to-point and integration bus approach, and we will see what were the differences between these things, so that you will get to understand the Mulesoft architecture in a very much good manner. And we will see how a Mule API lifecycle is in today's class. Okay, so first and foremost, we'll just see what is an API. You're able to see my screen, right? Just a question.
Yes, I'm able to.
Okay. Yeah. So yeah, thank you. So first and foremostly, first we need to know.
Hello.
Yes.
Hello. I am unable to view the screen.
You're unable to view my screen. Actually,
Yeah.
I'm. Okay.
Yeah. Now I am.
Now you are able to see my screen, everyone.
Yeah. Now it's visible.
Okay. Thank you so much. Yeah. So. First and foremostly, basically, we need to know an API because Mule is used to develop APIs. So that was the reason. First and foremostly, we need to know what is an API. So generally, an API is an acronym for Application Programming Interface. Okay, the name itself indicates that it was an interface. Interface, what it will be generally doing? It will be acting as an intermediary, which will be allowing you to two applications to talk to each other. So that it will basically, one might have a different language, as like an XML or like a JSON, and other might have a different kind of language. So it will be acting as a middleware. Okay, it will be acting as a software which will allow two applications to talk to each other, which will be communicating in different languages. It will make them to talk to in a single place. Okay, so let me tell you an example. So when you generally use an application on your mobile phone, say you search something on your Google server, what it will be doing, that your application will be connecting to your internet, and it will be sending the data to server that the user is searching for this something. Then what it will be doing, server then will be retrieving the data, interprets it, and it will be sending back to your phone in a readable format. That is the reason when you search something on your Google, it will be fetching your data from backend Google server, and it will be giving it back to your phone in a readable format which will be understandable to you. This was nothing but backend, and API was working. An API was present in between these things. Not only this one, if you search something on Uber, okay, you take something like Facebook, you will be checking your weather on your phone. Everything there was an API. Okay, so this is the importance of an API, right, which will be allowing you to talk to each other. If you just read your database directly, Google database, without using an API, you can't understand that language. It might be an encrypted code, it might be in some other language. So an API, what it was doing, you were for readable language to the database readable language. It is acting as a middleware part to transform the data to one language to other language. So as of now, you just remember that now what is an API? You might have been gotten clear idea that it was nothing but a software intermediary or an interface, right? Which will be allowing the two applications to talk to each other, right? So next coming nextly, actually, what is a web service? Okay. Just a second. Yeah. So what is a web service? So web service, what it was like, it was also used to exchange the data between the systems, right? Between two systems or two applications. Then what is the difference between these things is here, this is nothing but you will have certain protocols. Protocols are nothing but rules, okay? Set of your standards. So how you need to transform the data, right? Here, if you say some example, right? There were two systems like system A and system B, right? So in this system A, you might have XML like XML. So XML is nothing but it is a very strict schema. How it will be there? You need to give the first attribute like A and second attribute B. Then the B must come definitely under A because XML is tagged to schema. So the schema, how it will be there? It is nothing but how the order was very much important. We are defining set of rules and standards between those two systems to talk to each other. You need to send this example and you need to send this thing. So there will be two types of web services generally. Simple object access protocol. This is used for XML related transfers. Okay, XML related data transfer, you will be using it. The next one is coming for REST, representational state transfer. This is used for any format of data transfer. Okay, say it might be XML, say it might be JSON, say it might be Java, whatever you name the particular thing, we can do it in REST. Okay, so that was the reason REST was more popular nowadays, and you will be developing the REST APIs and REST web services in Mule. Okay. So we have seen what is an API and we have seen what is web service, right? So, but it was like now you might got a doubt that it is used to interact between two different systems at the same to talk to each other. Then what is the exact difference, right? So the main and mostly difference you can say is web service will support only HTTP protocol. While coming to an API, it will be supporting HTTP and HTTPS. So what is HTTP? HTTP is referring to Hypertext Transfer Protocol. Protocol is nothing but rules. So when you search something on your Google browser, so that URL, what does it start with? HTTP:// something, right? So that means that it's not a secured one. The protocol or the URL which you are trying to use and to invoke that particular API, it was nothing but it is a web service because it only supports HTTP protocol. Whereas your API, it will support definitely HTTP1 and also the HTTPS. That means that it was also used for security purpose. So API will be supporting both the things. So by this point, you can just infer one more point saying that all the web services are APIs because all the HTTP protocols, it will be implemented by API. But all the APIs are not the web services. So just now you have to keep a point in your mind that API is more advantage than the web service. That was the reason web services are being replaced by APIs nowadays. And web service, to say definition one more time, web service is nothing but a collection of open source protocols and standards which are used for just exchange the data between two different systems or two different applications. Whereas API is nothing but it is a software interface which will be allowing your two applications to interact with each other without any user involvement or something. Okay. So now we have seen what is an API and we have also seen what is a web service and we have seen what is an advantage of an API over web service. So what is Mule ESB? Okay, so before we go into Mule ESB, what is a middleware? Let us know first, because Mule ESB is a middleware tool. So middleware, what it is doing is, so here generally it is used as a communicating system. Middleware, the name itself is using, you have something known as front end, you have something known as back end. But a middleware, what it will be doing, it will be connecting to your front end to back end systems, and it will allow you to transfer your data to it. You can't write all your logics on your front end, you can't, at a DB, you can't place all your water transformation part. In a middleware only, whatever you want to write, how is the logic needs to be done, at what time the DB needs to hit, all these kind of logics, okay, all this set of rules and all these things can be done in the middleware. So here nowadays, Mule is nothing but it is a middleware tool. Okay, to say more precisely, it is a lightweight Java-based ESB platform. Okay, ESB or middleware both were the same. It was middleware, nothing but it was an enterprise service bus. Try to understand this terminology. Enterprise service bus. What is a bus generally do? A bus generally takes people from one place, okay, and it will allow and it will just drop them at whatever the place they need it, right? So the same way, the same terminology you can really connect to here in real time as well. This was an enterprise service bus. So this service bus, what it was going to do, it will allow take data from one service or one API, and it will just ask to transfer to other API, and it will allow those two systems to communicate to each other in the common language, okay, in the common language. So this was nothing but it was a Java based, because whatever we are going to develop, we are going to do it in the format of, because here whatever the tool which we'll be doing, it was a pure Java based Eclipse format. But the advantage over this was is it is a lightweight. Why I am saying that it was a lightweight? The fully loaded distribution network of Mule is not more than that 40 MB. Okay, and okay, one more thing you can say in Java, if you write, you might have people have seen writing each and every line of your code unless of suggestions, right? But here most part of your code is written in the form of a connector. Okay, we'll see what is a connector. In most part of that, there will be some connectors or some components pre-existing in Mule palette. There will be a connector for a database, there will be a connector for SAP, there will be a connector for Amazon Echo, or whatever it will be for files or for HTTP connecting, HTTPS connecting, whatever it was a different backend systems or different front-end systems, you will have all the connectors, right, in Mule. So what you want to just do is you just need to drag and drop. Okay, you will just drag and drop, and you need to just give whatever the configuration parameters. Okay, so let's say when we want to connect one SQL DB, right? Whenever you want to connect SQL DB, what you will be doing, you will be giving that username, the password, and the whatever the service name, whatever the port and URL, right? That's it. So these only 5 rules. Here in Mule also, you just need to drag and drop that DB connector, and when you drag and drop, it will ask for a few parameters to write. So these 5 parameters, whatever, how do you connect in SQL, Oracle SQL developer, in the same way, these 4 or 5 parameters, you will just keep it over here, these things in the in this configuration thing, and you will just connect it, right? That's it, nothing more than that. It will automatically take those dependency jars, and it will create a new database connection for whatever the operation you are going to do. That means that it has avoided the number of lines of code how you used to write in Java. For connect, you need to set up a new connection, then you need to connect it, and you need to give all these parameters and hard-coded values, and then you need to give again prefer those parameters. So instead of all these steps, right, you will just drag and drop the connector, and you'll just give however you'll do in other tools. In the same way, you can do it over here as well, instead of establishing a connection again. So this was the advantage part when you start developing your code, or when you start writing all these transformations. This is just simply a mapping. You don't want to write lines of code. It's simple mapping. That's it. You need to drag and drop the connectors, and just whatever which parameter, you can just drag and drop those elements. The code will be generated automatically at the backend. So here, that was the reason this Mule was very much advantage over the different tools, right? And here we will allow developers to connect applications together quickly and easily, so that it will easily enable them to exchange the data between these 2 applications. So if you want to see a definition of Mule ESB one more time, it is a runtime engine of any point platform. Okay, what is any point platform? We'll see now. So it was a lightweight Java-based enterprise service bus or an integration platform you can think of, which will be allowing your developers to connect applications together quickly and easily, enabling them to exchange between those two applications. Okay, so now why Mule is trending currently? Okay, before Mule, there were many middleware applications. We should not say that there was no middleware before Mule. We have Oracle, OSB, we have TIPCO, we have so many things, these kind of things. But why only Mule is trending more than these tools? Why only Mule was trending currently? Because okay, let us try to understand this architecture, how it was there as a direct connection. Then you can understand pretty much clear in Mule. Okay, so here this approach is known as a T2p approach, nothing but it was a point-to-point approach, right? So here we have multiple systems. Let us say there was an organization. Okay, in that organization they might keep some databases, like one is for sales data, one is for customer data, one is for account information. Each way they might keep all these information in certain databases, right? And they might have certain packaged applications like SAP, Oracle, IBM, and they have some things, you know, they want to keep this information engaged in multiple social platforms, and they might have been sharing all this information through mobility and through some devices. And they might have some certain customized apps which they have might be written on their part, and they might have been sharing this information on the cloud platforms like Google or Windows or somewhere. Okay, so what happens here when it was an everything point-to-point approach. So nothing but here it is a direct connection based. Okay, here you don't see any kind of bus or any something. It was entirely a point-to-point approach. So if you can see here this customized app, this was directly connected to your LinkedIn or your Facebook or Google Plus, whatever it might be. Okay, here it was directly connected to, if I want to connect for every connection, there was each and individual connection was made. If what happens sometime, if I want to add one more database over here, right? If I have 60 database over here, well, I need to connect it to every application in the organization, right? So one connection to custom apps, one connection to packaged apps, one connection to here, and all these things, right? So what will happen here is, so when you do these kind of things, right, when you just keep all the connections more, it will become messier. And when you want to maintain also, when you want to give a support also, it will look very hard to change. Okay, and when I want to remove certain connection, it will be very hard, and it will be very much high risk as well. Why I am saying high risk is, see, when a bug, okay, when some vulnerability has occurred to this particular connection, right? When a mobile was connected to database to get certain data from thing, so this connection might have been got a bug, right? So let us say one bug has occurred. So this was having a direct connection. So this mobile is also connected to some customer partners, and it's also connected to this custom app. So what will happen? This not only affect this particular thing. If you just remove this particular connection, or if you just debug this, it won't suffice your need. You need to do all the connection changes. That was the very hard part on point-to-point approach, because you don't have any middle system, right? And if you time to market will be also very much high, because when I have introduced one more packaged application known as Salesforce, okay, let us say Salesforce, when I keep a Salesforce, okay, when organization has thought that, okay, let us introduce Salesforce as well in our organization, and let us make connections. So when I just kept it here, so I need to test Salesforce to customers connection, to test Salesforce to database connection. I need to test the connection with whatever the APIs or with whatever the apps which are already present in the organization. These all the changes, I need to test it, and then only I can deploy it in cloud, or I can release it to production. So this means that the time to market is very much high. Right, so to overcome all these disadvantages, right, whatever we saw, the bug or high risk or the maintenance or whatever hard to change, and the time to market to very high. So whatever is all these changes, all these disadvantages, to overcome all these things, we have got an approach known as API-led connectivity. So the API-led connectivity. So what is API-led connectivity? So we have seen what is API, right? So what we will be doing over here is, when we are going to develop our APIs, we are going to distribute your APIs to 3 parts, right? So it was system APIs, process APIs, and experience APIs. So whatever the systems you have seen here, right, backend, right, these databases of the custom applications or SAP, Oracle, IBM, whatever it was, we'll take all the SaaS as whatever FTP or databases, whatever the backend systems, you will place it, you will try to connect to system APIs. Okay, what are the system APIs? Okay, system API is nothing but, you know, already we have already seen that it is used to connect to 2 different applications to talk to each other in a common language, right? So what does system APIs do is, it is a foundation layer of all your APIs. So you can see here, which is various organizations, sensitive information will be present, right? Or there is sensitive information will be present in the databases, because they will have sales information, they will have customer information, whatever you name these things, they will be present in these backend systems. So here, whatever we are going to do is system APIs. We'll develop one system API to connect it to database, right? We'll develop one system API to connect to FTP or files. We'll connect one system. We'll develop one system API to connect. I'm saying that we are going to develop. We are going to develop. What does it mean? We are just going to take the drag and drop that connect, and we are going to just give the configuration and just going to select star from. That's it. System API was ready. So why we are going to do that? When we go to process API, I'll tell you the advantage, right? So system API, what I'm going to do is, I'm going to just hit the database and I'm going to fetch the information, whatever database, and I'm just going to keep that information. No logic I'm doing here, no processing I'm doing here. I'm just trying to connect to the backend systems. So that was the reason it was named as system APIs, as I'm connecting to backend systems, right? So here, one more thing I can say you here is, these can't be, or these won't be published for exposed for public use. Why? Because as I've already said you, the organization's sensitive information will be present over these backend systems. So when we should not expose the public information, so the sensitive information to public. So that was the reason system APIs, we never give the URLs to any public or any end user, right? So in the next API, what it is process APIs. So what is this? The name itself indicates that these are for processing your data. So am I going to connect to your database? No. Why I have connected to database? I had already connected to database and I had already got fetched my information one time in system APIs. So definitely I'll connect process API to system API. Instead of giving connection to again database, I'll just connect to my system APIs. So here what you can see, here the connections have been reduced. Database is connected only once, you can see the connection. So database is only connected once. Instead of these, right, database, if you take one more new application, here what you will be doing, here you will be connecting every time individually. But here, as I've already connected to once and I have developed a system API, if one more end user come also, I just connect to this system API. I won't again be calling the database or any more time, right? So system API was that much advantage. Okay, so process API, what I'm going to do, as I've already fetched the information of database into system API, I will take that as an input to my process API, and I want to perform any logic. Okay, what will be the logic? It might be defined on your backend systems, right? Your front-end systems. So they might want you to filter the data. They might want you to split your data. Database might have been so much of data. They don't want all the data. They want filter or certain conditions, or they want to transformation, or they want to route to some particular things, right? So those kind of orchestration or those kind of processing logics you will perform in process APIs. And the next and the topmost layer is experience APIs. So it is used for user experiencing. And okay, one more thing, let me say, I forgot. So process APIs also can't be exposed to your public. Why? Because it was also containing the logic which the organization is using. So you can't expose the logics also to the end user. So that was the reason you won't be exposing the process APIs also in the to the public use, right? So experience APIs. So it was the purposeful built APIs for an end user. Why? Because see, here there was a mobile, right? Here there was a web, and there was one more user, right? And here what I want to do is I want to show that show the data to the mobile in the format of graphical format. Okay, so when some map is going, okay, you when you open Google Maps application, so there will be something known as graphical view, where from one destination to the other destination. So in that way, you need to show the data format when you comes to the same data. Okay, the same database data, I have processed the same logic, and here I want to show it in a graphical format. But when I want to see on a web or some other place, I want to see in the format of an XML, or I want to see in format of JSON, right? So how I'm going to do, as I have already had the connection to database and system API, I had already had the logic in process API. In the experience API, I'll build now two experience APIs, right? One experience API, I'll just keep output in the format of the graphical format, okay? And the other one output in the format of a file, or the other one on the output format of an XML, or say JSON, whatever it might be, the output format, the text or Java, whatever it was. So I'll develop each individually. Experience API, here in experience API, there was no connection, there was no process. It was only and only for end user perspective. So here I am going to just throw that particular one experience API output to here end user, the other experience API to end user, right? End user. So here you can see advantage of API. Experience APIs now will be exposed to public use. This particular API URL, where say it might be starting with, if you want to most make secure, HTTPS, and you will be keeping it. If you don't want to just secure and is fine, and not a non-secure connection, you just keep HTTP, and you will just provide that particular connection URL to the end user. So these can be exposed for public use, because you don't have any, you're not exposing any kind of sensitive information or the logics which your organization is following. So, so now you can see, so I just let me report one more time. So here an API-led connectivity is nothing but it is consisting of 3 layers. One is system APIs, one is process APIs, and the last one is experience APIs. So what it will do is, so the system APIs, what it will be exactly doing, it will be connecting to your backend database systems, and it will just retrieve or fetch the information and just place it over system APIs. So, but it doesn't consist of any kind of logic. Process APIs will take the input from your system APIs and perform your orchestration or develop any kind of routing, transformation, or splitting, any kind of logics. All the process of your logics will be performed in your process APIs. Then comes the experience APIs, which will take the input from process APIs and it will just give it to end user, or end user will be experiencing these APIs in the just the output format of the differing. That's it. So experience APIs is the only APIs which will be exposed, and the URLs can be shared. So now we have seen this API-led connectivity. So this is the architecture which Mule is following. So now you can see we have seen already the disadvantages, right? Let us see how these disadvantages are being overcome by this API-led connectivity. Now we have said that it was a hard to change and high risk. How this was not high risk, why I say. So now what I can do is I'll whenever a database or whenever an API has been, there was a bug entered, and whatever we are going to do is I want to just remove this particular connection. This API is not at all directly connected to this particular user. So if I remove just this connection and develop one more system API for this database, it will be very easier. And this process API connection, I'll change it from this system API to that system API, and this whole part is not going to affect it at all. Unless of previous thing, I need to change the entire connection. Here you won't need to do in that way, right? And if I had added one more web service, okay, one more SaaS application, says in the same example how we have seen, one more SaaS application like Salesforce I have added, I'll just develop the system API and I'll just develop the process API. If it is the same logic, I can reuse the process API, how the database logic was there. In the same way, if it was going to work for Salesforce, I'll reuse the process API. Otherwise, if there was no different logic, I'll just develop process API. But experience APIs is not going to change, because here the same thing is going to be repeated. So as this part and process API and experience API is already tested, right? Every time we develop an API, we'll be testing that API, right? So already tested, right? So here only this particular connection to system API, we'll test it. That's it. As this is already well tested and already well deployed to the cloud or any environment, we'll just test this particular connection, and the time to market is not that much high when compared to here, because when I try to enter a new application, here I'm going to just, what I'm going to do, I'm going to add to all particular connections and I'm going to test each and every connection. But here I'm not going to do in that way. I'll just test your SaaS application or Salesforce application connectivity to the system API. And then what are you going to do? So these three things, how you are going to do is, the remaining things will be as it is, and you'll be testing only the particular part. So this API-led connectivity is your example for Mule architecture. So that was the reason, as we have segregated and separated, and we had advantages, more advantages. So that was the reason actually Mule is trending right now currently. So am I clear so far, or any doubts till now? I'm considering as a no, and I'm just going to the next screen. Okay. Yeah. Thank you so much, Vamsipriya. Yeah. So next one, when you come here, so let us see what is a Mule life cycle. Okay. Firstly, we have seen what is Mule. Okay. What is an API? What is a web service? And why we are developing APIs? And why Mule is trending currently? What were the advantages of Mule over the previous technologies or previous things, right? And so now what is a life cycle? Okay, so first and foremost, let us consider this inner circle first. Okay, first and foremost, you need to design your API specification, right? Let us understand the terminology. So what is an API specification? So API specification is nothing but you will be designing your how an API specified parameters needs to be. So so I said an API is nothing but two different applications which will be talking to each other in a common language, right? So here a system A, right? First system A, let us say two systems, right? System A and system B. So two system APIs, sorry, two systems will be connecting to each other through an API. So what is now happening is, now system A will have some parameters, like let us say it was something called claims information, right? Or something known as, okay, let me take an example of customer information. So when an Amazon customer, so if I want to tell one thing, like the request has to be replaced or request needs to be rejected, right? You don't want that particular thing, right? So whatever the details you'll be sending to an API, so you'll be just giving the details, right? Like your user ID, what was your password, and what was your order ID, and with what date you have taken the order, and like these kind, what was an item, right? How much was the cost? So these details was your request parameters, right? And in the system B, you might have these parameters. Will they be with the same name, right? In the Amazon database, will they be with the same name? They might have something else, like this order ID will be having, like there was only in like ID information. It might have some parameter, right? Here that might be an user ID. Here they might be, for you it was a client ID. So in that way, the parameter names might be differing, right? So in that case, what you need to do is, you will tell API specification, while you'll be designing it, you'll be telling that this client ID at system A is same as the user ID, the order ID at the system B, right? So you will just list down these request parameters and you will list down these response parameters of the other system, and in the API specification named RAML. So API specification, one of the API specification you'll use most extensively is RAML. So RAML, right? RESTful API Modeling Language. RAML is nothing but. So you will develop the RAML first and foremostly. If you develop your RAML, 60% of your work is done, because you are trying to give all your parameters like request, what are the request parameters, what are the response parameters, and what are the response codes. Like you will have HTTP status codes. Like, see, when you give some wrong URL, right? http://test.com or testapi.com in Google Chrome or any kind of browser, what it is going to give? HTTP 404, the page not found. So what is the 404 is indicating? It is nothing but the status code, HTTP status codes. So generally 200 series of status codes, like 200 or 201. So it means nothing but request OK and request created, right? And if it is a 400 series, right? In that 400 series, like 401 or 402 or 404, those series, those series were like, it was like for error purpose, right? And the that means it is error at URL. And 500 series is related to internal server related errors, like 501 is server error, 503 is something else. So in this kind of errors. So now you can see that those status codes, for the success response, what is the response? For the error thing, how the page not found is displaying. So these kind of response codes and responses will also be mapped in API specification. So, and also there will be something known as methods, HTTP methods. You people has already been meeting so many people. So you might have known get, put, post, update, delete. So get is used to retrieve your information from other system, right? I'm telling you that system A want to connect to system B, right? So what it is going to do, system A, is it want some information from system B, or is it want to update some information, or is it want to delete some information from system? So what method it want to invoke, what is the operation it want to perform while talking to each other, while communicating to each other? It is not the thing that every time it retrieves the information, right? It want to sometimes update the information, it also want to sometimes delete the information, and it want to create some new record in the database. That means that this information, so these are different HTTP methods. So you need to mention these methods also in your API specification RAML. So RAML mostly and very deeply will be going in 2 to 3 classes, but as of now you just remember that API specification will be designing first and foremostly RAML as in this design stage. Once you have designed, right, you will just model those API resources and these calls in the simulating stage. And once you have simulated and designed your RAML, you will be publishing your RAML to Exchange, named as Exchange. There will be one platform, actually, Anypoint platform, which was an online platform where you will be just creating the account with your own credentials so that you can just deploy your application to cloud. You can just run the application over it. You can just exchange. Okay, let me tell you. I'm so sorry. What is Exchange? So Exchange is nothing but, so the name indicates, right? You can exchange your APIs. So when you have developed an API, you will be publishing to, or when you develop an RAML as well, you will just publish to Exchange for other developers to contact and other developers to view the particular your API specification, and they will be giving you the feedback, right? So with that feedback, you will take your API specification and you will validate it, and you will want to, if you want to design your particular thing, right? If you want to change your any particular thing, you can do that change over here in this particular stage. So So let us go on this stage one more time. So here what I'm going to do is, first and foremostly, while you want to develop any API, it might be a system API, it might be a process API, or it might be an experience API. So first and foremostly, you will be designing your API specification, then you will be testing, and then you will be publishing to Exchange, and then you'll be validating to particular feedback from your architect or from your developers, other developers, and you will just test this again, this changes. So with this now, an API specification is ready, right? So that here the API specification is well designed and well tested at this stage itself. Now, by taking this API specification as an as the input, YAML as an input, you will build your API. How you are going to take now API request parameters list is there, response parameters list is there, and whatever methods, whatever operations you are going to do, all the list was present in your L. So what I am going to do is, now what I already said you, there will be multiple connectors to connect to your applications, or multiple connectors to connect to those particular databases. So you just drag and drop those things in your Anypoint Studio account, and then you will just start building your API, right? And then once you have developed your API, you test your API in the same Anypoint Studio. You can test it by using munits. How you will be writing JUnits for Java? The same way with for every flow, right, or for every connector to connector configuration or connector to connector connection, you can write each individual munit. So it is nothing but a unit testing at Mule, and you are going to perform it. So here, once the testing thing was done, that means an API was ready for publishing, right? So here, that means here an API specification was already tested, well tested, and with that again we have developed or built the code, and we have tested this particular. Also, we have done unit testing for every individual flow, and we have done a complete API testing. So that means that now the service with API is ready, and we have implemented, right? First we have designed it, and later with that design we have implemented the API. That means that now is the API ready? No, because what was the advantage of API over web service? We are doing it in a secured way, right? So API, whatever we have developed was not secured. We have just implemented the application, but we need to make it more secure, right? So how are we going to secure it? You can use many authentication methods are already pre-existing in Mule Anypoint platform. So what were there? So one might be like basic authentication, how we will just give user ID and password, right? The other second one is OAuth 2.0 or OAuth 1, right? So the thing with this authorization is used for generating a token. So it will be used to generate a token, and it is used to share those token only to system A and system B, so that only these two can use this API to communicate between these two applications. If some system C want to invoke our URL using the HTTP, whatever the URL I have given, so when they want to give that, it can't I mean to say it can't hit that particular API. Why? Because it can't get the data as I did not give, or I did not share my token with the that particular system apart from these two applications. Right? So this is one kind of authorization. And one more thing will be there, like client ID validation. Client ID and secret key will provide. We'll just generate them in from Exchange in the API Design Center. And then we will again provide those particular credentials to secure your API. So in this way, you can have multiple secure mechanisms. I have just said you 2 or 3 for example. So you will have still more secure mechanisms to secure your API, right? So once you have secured your API, now it was ready to deploy, because an API has been, specification has been tested, API was also built and tested, and you have already made it secured. So now you can deploy it to two places. You can deploy it to either on-premises or cloud as well. So what was the difference between on-premises and cloud? On-premises is nothing but private hosted platform. That means only system A and system B can interact in that particular platform. No other intervention will be explained. Okay, so the next thing is cloud. I guess most of guys, you might have known cloud. So this is a platform where it has so many things will be present, and in that cloud, right, you can deploy your application using Anypoint platform, or also you can deploy using the Anypoint Studio. So okay, you have deployed your code. So now you feel that okay, your work is or your job was done. No, still more 2 or 3 more steps will be present. Okay, those are not nothing much how you'll be doing in other applications and how you'll be doing in other platforms, the same steps. But here you will be you yourself can monitor, you yourself can troubleshoot them in the same platform. Here for everything, and there was only one platform named as Anypoint platform. So how you are going to monitor your applications? Okay, you have deployed your code to production. So generally in the lower environments, how it will be running? It will be running on one node, or it will be running on max of 2 nodes, right? So how it was performing in 4 nodes, right? In production or some in other higher environment, how it is performing the code, how it was performing, how you're going to check, how you're going to monitor your logs, right? That you can check the logs in graphical format, or in the at what time the application API has been hit, how many times the system A and system B has communicated today, how many times what is the data has been sent by system A today, what was the data set received to system B in this last 24 hours or 48 hours. So these kind of all API analytics, all kind of logs, you can monitor them in your API platform. And the next thing, okay, you have seen these logs. Okay, now you find there was some issue which was not present in LLE, nothing but lower level environments. So you did not face these kind of issue in lower level environment. You find that, okay, this was if more data is coming, right? So much of huge data was coming. Your application was not behaving or not responding to how it need to. So then you will be troubleshooting your application issue, right? You'll troubleshoot it, and again you will come back to API Studio, and you will again build it and test it, and again you need to secure this time. If you want to generate one more different token, then you will be doing it. Again you'll develop and you will start monitoring them. And then later, last but not the least part is next one is managing. Okay, what was there still to do to the API to manage, right? One example I can give you is I told you that 2 systems will be communicating to each other in a common language, right? So how many times this needs to communicate? Do you want to communicate every time in a day? Do you want to communicate these systems endlessly? No, right? Because see, there is some live example I can tell you, real time example. So if you had if your vehicle, you're just going on your road and you had some accident, right? You for that particular information, for the retrieval information, the motor vehicle record information, you'll be hitting MVR service from your based on your driver license number using that particular API. But whenever you will be hitting the particular MVR or MVR record database, it will be charging you some dollars or some pennies, okay, for hitting that particular database. So the system, if you can't communicate to it each and every time, right? So what you will be doing over here is you want to communicate it only twice or thrice a day. Let us say thrice a day. So I want to keep this particular rate limit, right? So between these 2 systems, I want to keep saying that system A is going to hit only system B only thrice. So I had kept this policy. What happens when this policy is exceeded? Okay, first time it has tried to interact with system A and system B, it will work fine. And system B system A and B second time, it works fine. Third time, it also works fine. But fourth time, when it will say, it will throw an error saying that the rate limit has been exceeded. It was only till 3 times. So now in how we have seen this policy, in the same way there will be multiple things like throttling policy, SLA based, whether it was 3 times or 4 times, okay? So only this particular time limit, right? So these are all the different kinds of policies which you can apply to your API so that you will manage your communication between the two different end systems. So as I think you guys have got a clear idea. So just one more time, just to recap. So first and foremostly, we'll just design the particular API specification or RAML, and we'll try to simulate it. Nothing but we'll try to expose it, and we'll try to publish to Exchange, and we'll take the feedback and validate it so that API specification will be ready. And then once the API specification is ready, we'll build the API, and we'll just test the application. So that by using MUnits. And now when the service with APIs is ready, I'll make it secure and then deploy to the application to cloud most probably, or on premises based on your requirement. And then you will be monitoring how the application will be behaving, how it was performing using logs, and then I'll be troubleshooting it if there was any exact issue. Generally on the cloud platform, you can troubleshoot using Runtime Manager. Or if you face really issues present, you'll just come back to this phase and you'll just try to do this. And here, once you have troubleshooted and you have seen that there was no issues, then you can just manage your APIs by applying some policies. That means that a fully developed or fully secured API was ready, right? So you can see that a testing was done at each and individual stages for every single API. So when I want to develop a system API, I'll just write, okay, let us say it's example of system API. So system API, what I'll do design, so that particular database connection, so that not connection, exactly database parameters, what are the different columns are present, I'll just try to write these things in this here. And with that particular things, I'll just build them. I'll just drag and drop the connector, and I'll just take all the parameters and I'll just showcase it as an output, and whether I'll just test whether the connection is being made successfully to connect to the database or not. And then when the API is ready, now I can make it secured, and now I can deploy it to the platform, and then I can troubleshoot if there was a connection was made properly or not, and I'll be just applying the policies for system API if it is needed. The same Mule API lifecycle is implemented for or if any case process API as well, or in any case the experience API as well. So whenever you want to develop it, so the testing is done each and individual stage. So there were very less chances to attacking to bugs or any kind of these kind of things, irrespective of the point-to-point approach. Now you can see how the API connectivity was still more advantageous, and again each API level as well, we will be following these many steps to perform the connection between two different applications. So that was the reason which Mule was implemented, or Mule was considered as the best middleware integration tool, and many projects were considering this middleware to connect to two different legacy systems. And whenever the mostly for transformation projects, right, they will be replacing the existing softwares or existing things by Mule middleware. Any doubts till now? Any doubts in any of the slide? Please feel free to ask me. Or any point you want me to repeat?
One quick question. I mean, all this process goes through a UI. What do you say? You have a UI to do all this, right? The process and the architecture, what you have been talking about.
Except this build, wherever you will be writing the code logic, right, processor, right, except this build, all the other steps you can do it in a single UI named as Anypoint platform. This build only will be doing on Anypoint Studio, named one tool will be there. It was an open source tool. You can just download it from Google Chrome as well. You can build your APIs in Anypoint Studio, which will be similar to your Eclipse. But whereas Eclipse, you need to write each and every line of your code, whereas this Anypoint Studio, they will be having connectors. You just drag and drop those things and you can configure them. That's it. Apart from this build, all other things you can do in the same UI named as Anypoint platform.
Okay, good. So everything is done through Anypoint. So Mulesoft ESB is linked to AnyPoint, or AnyPoint is the entire place where you do all this?
Mule is nothing but the runtime engine of this AnyPoint platform. So AnyPoint platform doesn't have any specification. It will basically do all these things. But backend runtime engine, how you're going to run is through Mule. Any other questions, Rahul or Sarita, Shrikant? Let's see. If any no questions, we can just wind up the class for today. Or do you want me to wait for 2 more minutes? I can just wait. You can just please feel free to ask.
Do you have another demo session, or this is the final demo session?
If you want me to just extend, I can do it. No, there was no issue with me. What were the things with any platform things? We can go with that demo as well now. Otherwise, if you want in the class,
if you want UI perspective, I wanted to have a look how it looks and how things go in that.
Sure, then. Definitely will go there. So, okay, so we know just a quick recap. Okay, so we have already seen the point-to-point approach, right? So how I have 3 multiple systems, right? SAP and Salesforce and multiple backend customer databases. So I have developed 3 APIs, right? The order status, order history, aggregate. So with these both the things, aggregated customer data. In the same way for mobile also, I have developed these 3 things, and I have given a direct connection for point-to-point approach. But when a bug has entered, right? When a bug has entered here, so this not only this system is going to affect, the system is going to give this web API completely, as this web API is already given a direct connection to order status, aggregated customer data. So these backend systems, not only this particular things, this entire organization is going to get affected when it is a triple way, nothing but it is a point-to-point approach. So the same thing you want to develop in a modern way, nothing but API-led connectivity, right? Now you will be developing, you can see here, order status and order history. I have developed 2 APIs. I just have developed the system APIs for each individual thing. And now I have developed order status and order history, and the same order status, I can give it to mobile API and I can give it to web API. I did not develop unlike this. I did not develop 2 order status and 2 order histories. I have developed only 1 order status, and based on that, I have just given a direct connection to your. If it is a mobile app API, it was given to here. If it is a web app API, I have given it over to here. So in this way, and if there was any bug has entered in the same way to this particular connectivity, so this part can be removed, as this was not directly connected to here. These other systems won't be getting affected, only the connection to this particular thing, these system can be removed and this API can be removed. This entire other system or the other other parameters or the other systems in the organization will not get affected. So now we have seen, right, how this Mule API lifecycle was done. So we will see how for each and individual thing, right, AnyPoint platform, how it you want to see. So first and foremost, you can see here it was a AnyPoint design center. So for designing for this phase, right, for designing your RAML or API specification, here this was the API designer, how the UI will be looking like, right? So here you will be mentioning what are the resource names, what was the different types, what were the different methods, whether it was get, put, post, right? And what was the responses, 200 status code, and how the format of your data, whether application/JSON or XML, how it needs to be exactly. So what were the different data types you can use, different examples. So when you start writing actually RAML, now then you can understand more pretty much clear, right? So these are all the different types how you will be writing in this API designer. The RAML latest version will be 1.0, where you'll be writing your RAML language, right, in your API designer. So the next one is Anypoint Exchange. As I've said you already, once you have done your API specification RAML in your designer and you have tested, right, then you will be publishing it to your Exchange. So Exchange, you can see here, all connectors are present, right? Or a connector is present for SAP, a connector is present in Salesforce. So all connectors, you name the connector, mostly the connectors will be present. You can also develop custom connector if you don't have the connector present, right? You can develop your custom connectors over here and you can just publish your thing. So once you publish your API specification, so in them it has named as banking API. So there was an option named as right side publish to exchange. Once you click here publish to exchange, it will automatically take you to this page, and here it will be asking you to publish, and you can just drag and drop, or you can just try to just keep that particular file. So once you keep that particular file from in here in your portfolio, in your organization, you can see that particular banking API as one of the API over here. So then this means that in that organization, the people, right, they can view your API and they can definitely give you the feedback. So and then after that, I can say one more thing was their API manager. So I have already said you, right, so there will be multiple policies to manage your API, like rate limiting or throttling or keeping a threshold and a SLA based, or you can give some secure things like OAuth token enforcement. So these are all are policies you will be having. Once you start click your API, when different policies you can just have, and you can have right side, right, the apply options. You can just give, if I just select this rate limiting and I just click on apply, it will ask me that how much rate limiting you need to give. So that it will just give 3 times. Then the fourth time when an API is hit for those 2 systems, it will just throw on this pattern, right? And these APIs, how it is can be coming to API manager is you can just import your APIs to this particular file, or once you exchange, once you just file, once you have directly in your API manager, you can see what are all the APIs present in Exchange, which we are published by you. The next and the most important one is Anypoint Studio. So here, Anypoint Studio, I've already said that those are all UI, Anypoint platform. This was the only one which was an Eclipse-based integration tool. Here you can see here in the right side, this is a tool palette. Here, these are all the connectors, right? HTTP connectors, Salesforce or HTTP, everything will be present. So those connectors, what you'll be doing is you'll drag and drop it to here. When you drag and drop it to here, you can see the request parameters and response parameters will be appearing. Why? Because we have already developed a RAML. We have already written those request parameters and response parameters corresponding to your components, so connectors. So those particular parameters will be present. So what you want to do is, when I want to keep this email to this particular mail, this connection, I'll just place it over here like a mapping. Automatically the code will be here written that email is nothing but mail colon is nothing but this particular I mean to say X path, or the path of still this component like payload.test.email. This particular line of the code will be written here, and you can test also the code, how the exact output will be, also what are the different values. If you want to give here only, you can test your code. Otherwise you can do it in vice versa if you want to write by the lines of coding on your own, right? So you can just give this thing, same thing in the just by writing on your keyword, so keyboards. Then also the connection will be made here, and you can see exactly the mapping into over here. So here in this advantage of the main thing was like these are everything will be visual edited. So just to configure all this API specification in your thing, and this Anypoint Studio, you will be it will be integrated already with your Exchange. I mean to say, when you just log into this Anypoint Studio with your Anypoint platform account user credentials, then you can directly deploy to the Cloud Hub or directly take something from Exchange, right? Basically, it will be connected to your Anypoint platform in the backend, right? it will when you just link your account to this Anypoint Studio, you can directly do this from your Anypoint Studio itself, like deploying or like for integrating with Exchange for it to import whatever the connectors are not present. You can just take those things. And also this was like a you can write munits also over here only. That means it's having an embedded unit testing framework, right? And the next one, last one is nothing but a runtime manager. You can, I already said you can deploy your APIs, right? And you can troubleshoot your APIs. So where you are going to do, this is runtime manager. So you can see as it already connected to this thing, right? So in this runtime manager, you can see what are all the APIs developed by you. And here, whether it has been deployed onto Cloud Hub server or whether it has been deployed to the on-prem environment. Then you can see, and the status was in started state. That means that it has been developed, it has been deployed into the particular Cloud Hub, and it was in a perfect condition, right? Or perfect, and it was in a running state. That started status indicates which zip or which jar file has been used, right? Which jar file was used to run your deploy your API, right? That particular zip file also you can see, so that what version of the code was present over here, you can just get to know. And also you can hear load balancers, and here you can keep alerts whenever an API has been hit. There will be something called as loss over down here. So there will be multiple things. So to check your API analytics or to check deploy your application here, that you can deploy either from Anypoint Studio directly. When you right click on your API, you'll just get an option called deploy to Anypoint Studio. You can directly do it from over here, or also you can do it deployed from your runtime manager, right? So here in this way, the Anypoint platform tool, this platform UI will be looking like, right? I guess I have cleared your doubts. Any other things?
It was good. Thank you.
Yeah. Okay. Thank you so much. If any other doubts, please, I'll wait for 1 or 2 more minutes. Salita, are you speaking something? I'm not able to hear your voice.
No, actually, I have a doubt. Like you said, we have to create RAMIs. Is there any inbuilt RAMIs, or is it mandatory to create by our own?
But it's mandated to create by your own.
Okay. So according to our process.
Yes, our project, whatever the backend systems they're using, so they will just let us know once they give those things, right? You need to start writing your own RAML.
Okay. Like, is there any?
If you have written one RAML by your own, right? And from the second time, if you want to reuse those RAMLs, you can do that.
So we can develop cross product RAMLs, or is it product level RAMLs?
No, cross product level.
Okay.
Yeah.
Thank you.
Okay. Thank you so much for all your time. With this, I'm just going to wind up the session. Thank you.
Thank you.
Thank you.